Hi, everybody. I'm Ben Capron, and this is the Specialized Bicycles podcast, where we go behind the curtain to talk to the riders and the creators who are sweating the details to make your ride better. And today, we're really lucky to be connecting with Seb Servet, the lead engineer on all of our road products, the man behind the whole team that's created bikes you may have heard of, like the Tarmac SL8, as well as what we're going to talk about today, the Aethos 2, and with Alex Jerome, the leader of our product team on all the road bikes that we create, the guy leading the entire team to look at what do riders need and want, and how do we create the products that can satisfy those needs as we help people have the ultimate riding experience. Alex, thanks for joining. Seb, thanks for joining. Let's jump right into the Aethos 2. I gotta say, I'll let the cat out of the bag. My personal favorite road bike, because it's a bike that's so pure in the riding experience that it delivers. I wanna start with different types of riding on the road. Let's start big, right? There's different ways to ride bicycles, and different riders have different things they want. I would love to hear from you the way you think about like a tarmac rider, let's say, versus an Aethos rider. Who are those different riders? What do they want? And how do you start to tease that apart when you're looking at creating a product offering?
It's a great foundational question, actually. But it's actually pretty simple for us. I mean, when we look at tarmac, the rider for us that we're really trying to make the product for is our World Tour athletes. That obviously trickles into everyday riders, whether they're out for a ride or also just going to a local crit or local road race, or racing at a pretty elite level within, let's say, domestic scene or something like that. But really, we're just trying to serve and focus on those World Tour athletes. So that becomes a pretty crystal clear focus on what we need to provide them.
I'm just going to jump in for a second, because there's a big difference between simple and easy. When you're saying, yeah, we're focused on what Lotte Kopecky needs or what Remco Evenepoel needs when he wants to win the Olympics. Like, it's simple. Okay, yeah, it's simple. Like, make me as friggin' fast as humanly possible. This isn't a tarmac session, but I just want to say, I like the simplicity. There's a whole nother thing we can talk about another time about how hard that is to realize.
Process of getting there, maybe not simple.
Fair enough.
But rider need, pretty simple in that
good.
case for Remco and Lotte and stuff like that. You know, we have tarmac, pretty simple in terms of what we're focused on. Same with Aethos. Again, it's like that bike is all about paring it back to just, you know, the ultimate simplicity. So we have that performance baked into it from a lot of that perspective, but we also have just, you know, the pure simplicity and enjoyment of riding a bike like that has, great compliance, great comfort, and just great handling. It also, I think, has a bit more magic baked into it than tarmac. Certainly its own feel.
And we're gonna get into that. And I love where you took us to the magic, to the ephemeral, the feeling of the ride that we know and love as people passionate about cycling. There's no top step on that podium. It's very personal. It is a magic essence. And essentially, the bike was engineered to disappear underneath you, right? I think about that quote that perfection is attained not when there's nothing left to add, but nothing left to take away. Yeah. And I think that that's so central to what you did. And when you feel the bike on the road, it's the essential experience. The purists are really loving this bike. People who know the difference of the way a bike can feel underneath you, incredibly responsive, incredibly intuitive the way it moves, but also magic in the way that it moves over the surface of the earth. Yeah. And I love how in pursuit of that magical ride experience, you ended up making as a team the lightest production road bike ever. 595 grams. That's why it breaks the rules. It's too light to be raced by the UCI, because on the racing side, riders line up, the race starts, there's a finish line, it ends, someone was first, someone won. And you guys can deconstruct that. What does that mean in terms of power transfer, aerodynamics, all these different pieces? But the goal is very clear. When we're talking about the magic, right, on this machine that's the most efficient form of human transportation ever devised, this pure 7 tubes, a drivetrain, a human being riding on it. Can you share, with the folks tuned in, what are the complete bike weights, maybe from the S-Works at the top and just a couple of the other complete bike weights?
Yeah, absolutely. So for the Aethos, we have S-Works Pro and Expert in that line. S-Works is obviously, our pinnacle Halo flagship level. So right now with pretty much an inline build, you're getting a bike that is at 6 kg or right at 5.9 kg. So,
and how many pounds is that for our American friends who are way behind the world on the metric system?
This is embarrassing, but I live in a world of kilograms now.
It's 13 pounds. It's a 13-pound bike, just a hair's breadth over 13 pounds.
It's light. You pick it up.
A complete bike.
It feels ridiculous.
13 pounds.
Yeah. Yeah.
What? Holy smokes.
Holy
smokes. And 595 grams is less than a water bottle that's not even full.
Yeah.
Way less than a small water bottle, not even full, for the frame you're riding on. So we're saying it's not about weight, and it's not. But holy smokes, that is light business.
It's fun to talk about the weight.
It's fun to talk about. It's fun to ride a machine that's that
Absolutely,
light.
yeah.
Amazing. Okay,
Yes.
I just wanted to hit that point and see what that actually meant. And of course, that lightweight, right? It translates to ride feel.
Yeah, I mean, it's part of the feeling for sure.
That's
it's part of the magic.
This bike says, I don't care about the rules.
Yeah.
This is about winning at a whole different level. Aethos 1 came out. It was discovered. People loved it. It's this beautiful riding machine. Now it's Aethos 2. Break down the differences. What's going on between Aethos 1 and Aethos 2? What's the big innovation? What's the shift? What's the change?
It's really refinement. I mean, we were pretty happy with the ride quality and handling characteristics that we had from Aethos 1. But the main differences were a couple tweaks in geo. Super small, but just makes the bike more confidence-inspiring, especially descending. That's a little bit slacker head angle. We also added about 15 millimeters of stack on the head tube. So that just opens that bike up. It was pretty somewhat aggressive fit, but that definitely adds the opportunity for more riders to get on that bike and be comfortable right away with that additional stack. We also have UDH on the bike now. So nothing crazy, but something we definitely needed to make sure that we could spec all the drivetrains that we wanted and riders could build the bike they wanted. But the other big piece, again, just going back to that simplicity and elegance and definitely modernizing the bike, is we have the new Alpinist cockpit on there from the Roval team. So I think that's also a piece that makes our bike so special is, yeah, we developed that, and we're obviously talking with like all of our teams across the brand, whether it's wheels, cockpits, obviously the chassis that we're designing and engineering, and all of that just comes together into a pretty fantastic package. But on the new bike, we have the updated Alpinist wheels and we have that updated Alpinist cockpit. So all internal cable routing, so it looks clean, sleek, modern, and yeah, just ups the elegance level.
We're at the top of the show still. People want to know Aethos 1, Aethos 2. Recapping a couple things. 1/2 degree slacker head angle, providing just a little more stability.
Yeah, absolutely.
For this amazing dancing partner when you're going through the turns. And how did you discover that 1/2 degree would feel better? How did you land on that?
I mean, I think the teams have a lot of knowledge on geo and geo adjustments. So I think, yeah, the main goal was we don't want the bike to feel any different than the original Aethos, especially, let's say, going uphill. It has that magic. It feels amazing. But descending, we just wanted a little bit more stability, a little bit more confidence, and yeah, those small tweaks just help us get there. Especially, we also increased the tire clearance up to 35 mil tires. So that's going to add a little bit more just kind of stability and comfort for riders as well.
Seb, how did your team increase the head tube, right? Add UDH. These things add material to the bike, but still create the lightest production road bike. We're gonna get into that. I want to get into something that is a theme in this bike though right now, which is 1/2 degree, right? We're talking about little details, but I've ridden Aethos 1 quite a bit. When I rode Aethos 2, I felt both the familiarity of my personal favorite road bike that I've ever ridden of Aethos 1, combined with something I didn't even know was possible, which was just dialing the knob that much closer to perfection.
Yeah.
And I'm very, very curious, and we've never talked about this before, so I don't know what you're going to say, but how do you, it can't be that it's a half a degree on paper and that's it and we lock. Like there's something going on, I'm sure, between the technical expertise of engineering, material science, geometry, all that, and what it feels like to ride that you can't get just from numbers. How does that work? How do you bring it together to know what's going to be that much better? The intangible. How do you bring that together?
How do we maintain, the great ride feel and the great ride experience for which the Aethos is renowned for, and just, tweak the details and find a solution to make the bike ever so slightly, more confidence inspiring in the sense. And so rapidly we came to this, proposal. How about we change the head tube angle? And so what we did, as we often do at Specialized, is we just created a prototype, a mule, as we call it. And so, we have great team and great craftsmen at Specialized that can help us do these prototypes. And so we did, right? So we put the bike and we put a lot of hours actually in this mule. Everyone was excited, right? About, oh, wow, what did you do, right? It was very obvious that this bike had something special, this prototype. So everybody jumped on it. And yeah, quite rapidly, the team realized, okay, we're onto something here.
Great. I'm gonna butt in on you because I think that right there, you just went very swiftly over a piece that we're talking about magic.
Yeah.
That's a part of the magic. And the magic is to have the technical capability to know how to create, but then the sensitivity that those same people, you and others on your team, you guys and others on your team can ride the prototype and feel as a rider, yes or no.
Yeah.
It's right or it's wrong.
Totally.
And having conversations with you, I know you sweat those details. You don't want it. You're not going to allow it to move forward unless it's right. But knowing and feeling what's right and what's not goes way beyond material science. What do you even look for in like teammates, or how do you guys gel in creating that alchemy?
The starting point of every novelty that we bring in our bikes is just what if. And then talking to our teammates, and we have incredible teammates at Specialized and incredible experts, and just talking to them, they would go above and beyond, and even on their own initiative, they can't help, as I was saying before, and they will, draft something on paper. And so, we have the simulation team or the structural analysis team, they made a few calculations of, hey, if we change the head tube angle, that's the result. That's how the weight distribution is going to change. This is, what we should change to accompany this slacker head tube angle. We have to adapt the fork rate. We have to make sure that we have enough toe clearance and all this sort of thing. So they put us on this lead of, you can try it and you should be trying this modification. And then they just validated that once we have, the experience from the field and we said, yep, this is good. Then we, the very last details we fine tune with the team and then we put that back in the machine and yeah, here we go again, right? Layup development and all of this stuff.
It's an iterative process.
Exactly.
But ultimately, it sounds like you let the ride decide.
Absolutely. Yeah. No, I mean, we have all these capabilities and wonderful tools and wonderful teammates, but we can't just, predict everything. That's just the nature of things, is we constantly learn from the field and from our riders. And it's really important.
It's so cool.
Not getting this feedback loop would be a terrible mistake.
Right.
You would iterate, out of a crystal bowl, so to speak, right? And emptiness. And that's not us.
I want to talk about something else that's a real thing that we talked about, and that's the increased stack. So the head tubes got a little longer. But again, it was an application of engineering, an application of real data. Our body geometry fit system and the database of rider fits. We've got more information of real world fits than anyone else has ever had in the history of time. And talk a little bit about the fit data that we have and how that informed the way the fit of the bike could be adapted to better suit rider needs and ultimately result in that little bit longer head tube.
Yeah,
Alex.
absolutely. We're super lucky to get to work with that team. And to your point, they have like an incredible amount of fit data that just can give us some really nice insights. I mean, I think long story short is the first Aethos had pretty aggressive fit. And at the end of the day, also how we're seeing folks riding that bike is, you know, less race oriented. So getting a fit that's maybe a little bit more comfortable for even those elite riders, but also just enthusiasts, everyday riders, we wanted to have something that is just a bit more comfortable. So adding that stack height gets you just in a little bit nicer position. And then to your point, working with that BG Fit team, like we also see where fits are headed for a lot of our riders as well. And that is increasing some of that stack. So now you have a bike that also not only gives you that stack up front, but when you're building your bike up, especially with that new cockpit and such, at that point, usually you can, let's say, reduce a few of your spacers that you're using as well. If you had 20 mils of spacers, now you're using 5 mils of spacers. So you also get a bike that looks a little bit more clean and aesthetically pleasing as well, depending on that fit. But yeah, I mean, all of it makes just, I think, a better package for that rider for sure.
Perfect. And just summarizing that. So in the fit data that we've got, we saw that a lot of the fits on the stock Aethos, the original Aethos, were coming up. People were putting spacers under there to get the fit, to make the bike fit their body, which is, again, the idea here, right? The ideal is body and bike become one. Be one with your bike is something we say sometimes. And so by seeing that data, you're like, hey, we can address that by growing the head tube a bit. Seb and team have a challenge of doing that without any weight increase, because that's no good. But then at the end of the day, we fit the riders we fit before, their stem might be down or even more slam, but that looks pretty sexy. And the riders who needed the upright fit, which was quite a few, have fewer spacers. So we're fitting people better. The optic is good. And let's be honest, the way we look is important. Hey, we'd be lying if we said it wasn't. So you've got the bike at the cafe, fewer spacers there, but a better, more comfortable fit. And of course, when you're riding, comfort is key. It's not just like being a slouch. It means that when we're in an ergonomic position, our body's able to work better. It's one less thing we're thinking about. Body and bike become one, engineered to disappear. That's awesome.
Comfort is performance.
Comfort is performance. Remco said, comfort is my weapon. I mean, we're not talking about winning here, but he said this really profound thing when we were talking with him about the Power Evo saddle. He said, hey, comfort isn't just so that I feel better. He's like, I'm willing to fall on a sword to win the race. We've seen him go deep, riding stages with broken ribs and everything else. But he said, no, comfort is my weapon, because when I'm in a comfortable position, I can stay in that position longer. So if you all can put me in a position where I can stay in my ultimate power position longer, I can unleash more of my potential. And that's really the key, right?
For sure.
It's the key that unlocks our potential. I don't know if that'll make it in the show or not, but I just had to share that piece because comfort's important.
I mean, it's true. I think that's one of the biggest things from our equipment team. Our mantra over there is comfort is performance, whether it's saddles or helmets or apparel, that type of thing. Yeah.
That's it, for sure. Okay. I want to peel it back a little bit. I promised we'd return to some of these ideas, but the breakthrough in Aethos 1 was significant in terms of the way, Seb, you and the team thought about engineering a carbon fiber frame, the shapes of the tubes, the carbon layups of the tube. So significant that actually it led to breakthroughs in this bike that wasn't the focus, the Tarmac SL8.
Yeah.
And we've been calling that internally like flow state design. But, you know, what is that? What was the breakthrough? How did that come to fruition? And what's the difference that has enabled you and the team to make significantly lighter frames than what anyone else is doing? And there's a lot of bright people in the bike industry. What was the breakthrough?
There was this moment where a colleague of mine and myself, and we were looking at a Tarmac SL6, that's already a long time ago, on the test bench. And there was something weird that we had never really observed before. And then my colleague of mine, we were just touching the frame, and it felt as if the frame was breathing. So what I mean by that is you could feel under really like this was pedal fatigue. That means that replicates, a hard sprint condition, really hard, tough sprint conditions. And under these particular loads, what you feel under your fingers with, your fingertips is that the frame is moving. Some areas of the frame didn't seem to, move at all, and some others were reacting pretty dramatically. And so my colleague of mine were like, hey, wait a minute, like it seems that something can be changed. It seems that something can be further improved. And so, yeah, by seeing these areas of the frame breathing or moving under a load, we just realized, hey, these areas are, there's some corners, there's some specific shapes and design features. What about we eliminate them? And what we also realized is this areas of the frame, so I'm talking about the head tube mostly, were areas where we also put more material for, to achieve the right quality. So stiffness layers, layers that, we add on top of the structure so that we can achieve several stiffness targets. So that was the initial point and the aha moment that led us to rethink or change our approach in how we design and have a more intentional design approach to where, we wanted to make sure that for the Aethos, we had a structure that would be way more efficient at carrying load. And hopefully we could remove some material.
So for the audience, this pedal fatigue test, the frame is fastened into a rigid fixture.
Correct.
Can't move at the fork and at the dropouts. Mm-hmm. And then with these hydraulic pistons simulating massive amount of force, the frame does flex under that load.
Yeah.
And you were looking with your eyeballs and you saw certain frame tubes breathing, flexing, and others not so much. Mm-hmm. And the insight was some part of the frame is working harder than the rest. And like a team, could we distribute that load more evenly through the frame, again, to bring the fibers into tension, deliver the strength and the stiffness that they're capable of delivering in a more efficient way?
Absolutely.
So this intuition through observation led you to an idea of changing frame shape that ended up looking so simple.
Yes.
So simple. Yeah. But actually the road back to simplicity involved so many elements. And then you had this insight. Take it from there. You change the frame shape. Tell me about the role of data sets and supercomputers, because you've talked to me about that before. And I just want to keep this story going. It's like this interplay between technology, technical competence, human insight that resulted in this alchemy. What did you do after the insight?
Yeah, so taking that insights, our first step was, okay, yeah, we have this intuition, but how do we turn that into a design and engineering process, right? And so that was a challenge. And rapidly, we talked to the experts in our, structural analysis team and asked them this question, like, we have made this observation, but now all of a sudden we want to change the design so that fiber can be, used more efficiently. Like, how do we get there? And their answer was, well, we need computational power that we don't have. So I'm sorry, but now this cannot be done. And so that's where we approached, companies that could deliver us this computational power. And we started to have, almost, 100,000s of different simulation and iteration. And each and every time, we combine this design change with layup change. And both, we realized that if you don't design for the material, then you're just design out of emptiness. And so what we entered in the computer was, okay, you have the power to decide what size the tubes may have, what shape the tubes may have, with the ultimate goal of reducing material and with the ultimate goal of having the entire structure carrying the load. And so these iterations obviously, took a lot of time, and we made a ton of mistakes in the process. But ultimately, what came out of the simulation just surprised us very much. The predictions from the supercomputers were that with the design that we ended up choosing for Aethos 1, we could achieve a weight of 560 grams. And that really shocked us. We couldn't believe our eyes. And so we started rapidly to build prototypes because we were overexcited, right? And yeah, it turned out to be
incredible.
It turned out to be true.
Incredible. So observation of breathing of an Tarmac SL6 led to this observation, had this idea, started to translate it, but you ran into a roadblock of computation. And again, just to translate for the audience, the FEA, the finite element analysis, is when you take a solid model of a frame, you put it into a computer, and the computer can simulate the loads, understanding the materials you're using, understanding the loads that are being loaded into it. And then it can predict and demonstrate and show you what areas of the frame are higher stressed, what's lower stressed. And here you're in that pursuit of trying to even that load out through the frame. And you went to a supercomputer that could run unfathomable amount of computations within this, but also an important piece, you load into that a data set of actual test data from the real world that's a bigger data set than any other organization has into the computer. So there's this incredible interplay of data that goes in, intuition, computational power, resulting in what seems devilishly simple, and using these extremely high quality carbon materials resulted in elimination of entire plies of material. Something that I bet if you had a junior engineer join your team and said, hey, what if we just take out some plies? You'd say, you're fired.
No way.
No way it'll work.
Exactly.
No way it'll work.
Yeah.
But what an incredible interaction, a dance really, between human intuition, employing these computer tools to lead to suggestions that you never thought would work, but lo and behold, they did. Absolutely incredible.
And I think you touched on a very interesting point, is also you have to keep a fresh eye, right? Because you said, if a junior had the idea, you would not have believed that. Well, as a matter of fact, as Specialized, we're very open for this kind of crazy ideas. And we don't reject them, with the typical approach of, hey, we're experts, we know better. But we're like, actually, what if he's right? And so, on the Aethos, what was really interesting is we saw physically, the model evolve over time, and we saw this plies disappear. And that was really a magical moment where you see the computer evolving in the iterations. You see the weight, dropping, and you see this plies all of a sudden disappearing.
We're going to talk one more thing about flow state before returning back to Alex and talking about a concept that you talked about earlier. Started with seeing an SL6 breathing, a long journey to go through supercomputers and data sets and FVA analysis and test jigs and But then here you are, you realize there's a more efficient way to use the material. What impact did that have when you returned to next designs after Aethos, like SL8? Did any of the learning from flow state inform what you did in this bike with a different intention to win races?
So absolutely, the breakthrough with the Aethos was pivotal in the way we approach the design and how we engineer, components and bikes at Specialized. And so, the takeaway from the Aethos was, you can use the entire structure to carry the load, and you eliminate the lazy parts, right? And on the tarmac, I guess the complexity was, the intent was not the same. You want to win races. And now, there's all sort of, rules that come on top of it. And there's a new constraint, which is aerodynamics. And so, we took advantage of the learnings of Aethos 2, and we added an extra layer of complexity with, computational fluid dynamics. So, once we had this computational power, we just pushed it once more to the limits, right? And we integrated CFD on top of it. And so not only did we have, this dialogue between, FEA and then design changes, but this time we had design changes informing both FEA and CFD. And so all of that combined, led to, again, a massive amount of data and a massive amount of tests that we run in virtual environments that we also combine every once in a while with some, physical tests, because we really want to make sure that we have not invested in something that would not be fruitful. But yeah, in the end, I guess, you just take the process, you take the entire tools that you have at your disposal, and push it even more to the limits, and that was the creation of Tarmac.
Very cool. You use a lot of lingo there. Yeah. CFD, FEA.
Yeah.
Translation, it's a BFD. But just to say the nugget in there in just plain spoken language, you and the team realized something with Aethos that was a game changer in terms of the way that bicycle frames could be designed. And that insight led to breakthroughs in Tarmac SL8, one bike to rule them all, an absolute weapon. It's so cool to hear, what goes into it from big concept down to realization of the smallest detail. Massive respect to you and to the team. It doesn't happen by accident. It's a big devotional act. So it's so exciting to hear about that. It's like, I'm not an expert, but I'm listening and I'm like, it's so cool. And then to feel what it feels like it makes a difference. It makes a difference in people's lives. For myself, I love to ride early in the morning. And it's like when I ride the Aethos, I live in Marin County. I do this one ride in the morning. I ride up Mount Tamalpais. I usually start in the dark. I'm riding up along Bolinas Ridge. The sun is coming up. I was riding Aethos 2, and I was descending down the mountain. And I had this, it happens relatively frequently, particularly on the Aethos. I had this moment where I was outside of myself. I was purely in the moment, and my mind can often be busy. My mind was quiet, and it was that zone. I was in the zone. And it's the purest experience I have of living. And that is not a small thing, right? That's a big thing, to be able to execute your craft to the point that you can provide a machine that helps a person have a deeply meaningful experience on the bike. And I think that's, for me, that's what I'm always like, you get a taste of that, you want more of that. And different people find it different ways. Like maybe some people get in that zone playing the cello, like God bless them. I find it on a bicycle. Alex, I wanted to turn to you for a second and return to something that you mentioned at the beginning. When I asked you what's different with Aethos 2, one of the things you said was about the cockpit, and also I want to talk about the wheels. But first I want to say, it's one way you could spec a bike and look at a bike and say, here's the frame we're going to use, what wheels, what parts, what's the price point we want to hit, right? All that kind of thing. And those are important criteria. But the other one is to stay mindful about the intention of the bike and think about the reality, which is it's a whole. It's a holistic system. Everything on the bike, from the saddle to the bars, the stem, the wheels, the frame, it all has to work together. So I want to bring attention to particularly the cockpit and the wheels from Roval. I know both of those are significantly different. Can you talk to me about the cockpit and then maybe talk about the wheels? What's different about these Roval pieces, and why did you choose to employ them in the complete builds?
Yeah, I mean, to your point, it all comes down to system performance. Like, we can build an amazing chassis, but at Specialized, we're certainly more than that with all of the teams that come on board to make that product what it is. And I think for the Aethos, it's a more about the experience that we want the rider to have with the parts that we were building for that, being the new Alpinist cockpit and obviously updating that Alpinist wheel set. I mean, the new Alpinist cockpit is probably one of the more exciting pieces on that frame. That is actually one of the first cockpit that we've used, like going back to that retool fit data. We've used so much retool fit data to inspire like how that shaping of that cockpit actually is on the tops where the hoods are and even in the drops as well. So we have a cockpit that is much more compliant than what we have with, like, let's say a Rapide on the tarmac that's like a very racing specific cockpit. So you get the compliance, you get that kind of comfort. It's a really comfortable bar. It also, from a design perspective, it's a bit more elegant than what we have with like that full-on aero race aesthetic. So it just fits the bike and fits that vibe and experience much more. And then the wheel set is certainly where we've added, let's say, a little bit additional magic there as well. That team has totally revamped how that wheel set is running right now. We have all new spokes and hubs there. So we've actually moved to carbon spokes on that. So not only saving quite a bit of weight on that wheel set for the overall package. We talked about that overall build weight of that bike being 5.9 to 6 kg, depending on what you purchase. Yeah, so it's just bringing to life a pretty incredible overall system with the wheels, cockpit, and obviously the chassis. And the wheels are super special. I mean, the carbon spokes not only dropping the weight, they also just ride incredibly well. And I think going way back to when Seb was talking about looking at those frames and like having like efficient energy loading all over the frame when we have that on the test rig and stuff, it also, I mean, that is directly impacting that kind of really balanced ride feel as well when you're actually on the bike. So all of that ties together into what you're actually feeling when you're
incredible.
When you're out for a ride.
And we could do a whole episode just on the cockpit or just on the wheels. We absolutely could. I think that, you know, what you hit on there is so cool. And riding the new Alpinist cockpit, it's true. You feel the ergonomics of the system employed from data sets, employed from all that. And then when a rider who knows rides it, you feel it. You didn't even know you were missing it before, but when it's right, it's right. And the other thing, I'm glad you mentioned it on the spokes of the new Alpinist wheel set, because it's one thing to see how much lighter they are. It's one thing to feel and pick up a wheel set and go, how can that be? It's so bloody light. And it's another thing, like we've been talking about, to ride it. And the ride quality of those carbon spokes, to have the carbon between the hub and the rim, and so mediating the way the loads come through the bike, it's extremely precise, it's extremely light and nimble, but also it's like the static. Like if you have a radio that's not quite tuned in their static, it's like when you get it just right, and the static goes away and the purity of that ride comes through. I didn't even know I was missing it until I experienced it.
I would absolutely agree. I mean, not to sound silly, but the bike was already light.
Yeah.
But the ride quality is the biggest piece that like is a noticeable feeling and just feels amazing on that bike now.
I think that's great. And giving it the space and time in this to talk about it is great, because it's so easy on a bike like an Aethos to look at it. It looks relatively simple. Yes, it's beautiful. It's pure. Yeah. You look at the weight. Holy smokes, that's amazing. The first Aethos to Aethos 2, what's the difference? The difference is you guys turned the dial that much closer to the perfect ride when it didn't even seem like we could, but you did. And it's really something that's important to ride. So people who are resonating with what we're talking about, what it means to get into that flow state when you're in quest of what that really feels like, do yourself a favor, ride the bike, check it out, and then decide. You know, I think that's the key. Alex, I want to turn to you and talk again about riders, and particularly about rider first engineered. You're working with a lot of riders. You're hearing feedback. And rider first engineered, we first started employing this design philosophy back 12 years ago when we were hearing feedback from a lot of our pro riders. Big riders were saying, I wish the bike was a little bit stiffer. Small riders were saying, this thing is too stiff. Because the reality is a taller rider, more massive, larger frame, more likely to be flexible. Smaller rider, less mass, smaller frame, stiffer, it makes sense. But it led the team on quite a complicated journey of rigging up strain gauges on the frame, actually measuring actual deflection, and having another one of these turning point revelations. What if we started with the rider of each size and worked backwards to deliver the ultimate ride experience? And I want to bring that idea to you and ask, what is the feedback we're getting from riders of different sizes? Are they having similar experiences? How does Rider First bring itself to fruition in the Aethos 2?
Yeah, absolutely. I mean, bringing it back to the core of what you said, it's about having a great experience for every rider. So we don't just scale frames up and down depending on the size and let's say use the same layup on every frame. We are trying to have, we scale slightly different for each size and we have a unique layup for every size to try to get that experience to feel really similarly for each size frame. So it was potentially an issue in the past, but now we've gotten pretty good at that. So both with SL8, with Aethos 2, it's like we have pretty dialed layups for each frame size. So whether you're a larger rider on a 61, you're going to have a really similar riding characteristics, stiffness, compared to a rider that's riding a 49.
Fantastic. You know, when you were talking, it reminded me of the previous episode we did with Luke and Stuart on the new Diverge, because we had been talking with Matt Beers and Sofia Gomez. Matt Beers, nearly 2 meters
Huge.
tall. The South African diesel. I mean, that guy's numbers are insane, how much power he puts out. And Sofia, quite diminutive, a smaller rider. But literally the words they were using about the handling characteristics and the power transfer were the same. They both said, it's so precise in its handling, it's so reliable, and the power goes right through. And it's just a testament to this philosophy of always putting the rider first. Each rider, it doesn't matter what you guys do unless the actual human, the individual who rides the bike, feels the benefit of what you've engineered in. And it's such a logical thing to design that way. And it's cool that it goes down to not only tube shapes, which change, but also down to a different layup schedule, like the actual layups and plies of the material to achieve that consistency of ride across the full size range. That's amazing.
Yeah, I mean, your example is absolutely correct with Sophia and Matt. And it's like they're having a similar experience on 2 vastly different frame sizes. Yeah.
I think that brings us back to kind of where we started on this whole thing, which is really the deeper meaning. And when I think about all the products that we make as a brand, Aethos, I really believe this. Aethos, I think, is the most pure expression of pursuit of the essence of riding a bike. It is stripped down to the fundamentals so that we can help people have a feeling on the inside of what it is to move your body through space under your own power and experience that purity of a turn that just goes exactly as you think it will, so that the part of your thinking mind can disconnect and you can be fully in that moment. Like, what a beautiful thing. What you're doing is noble. It's important. As a rider, I appreciate it. I know I'm not alone. It's been such a cool journey to talk about all that goes into Aethos 2. And I just want to check, with each of you, are there aspects of Aethos 2 that we haven't talked about that you'd like to share with the audience today?
I think the only thing I would add is, you're talking to 2 of us right now, but the team behind a product like this is pretty incredible. I mean, we've been talking about the layup and such. I mean, we have a fantastic layup analysis team that is, I think, probably the most capable in the industry. I mean, just the team behind that goes into a product like this is pretty powerful and, much bigger than just the 2 of us for sure.
That's why you're such a great leader. You shine a light back on the team, and I think that that's so true. It's so many great minds, so much great expertise, and so much devotion that goes into the actual execution. It's one thing to do the work on the design, but all the way through the process, and let's not forget, all the way through, we've talked about a theme, the interplay of human intuition, observation, expertise, deep technology, and supercomputers, and all these different things, ultimately come back to something that's essentially human. What does it feel like to ride? So many hands, one team. And thank you for mentioning that. There's never been a team like this to create bicycles in the history of time. And it's why you can look and say, oh, there's never been a road frame this light. That's something that you can measure on a scale, but it goes way beyond that. What you are doing as a team is fantastic. It's exciting. I love the humility that you bring to it. So I'll blow your horn on this one. I'll just end maybe with that and say, Seb, Alex, thank you so much for taking time out of your busy schedule to share with us what you did on Aethos 2. I know you're deep into what's next, projects we can't talk about yet, but we will. So, hey, thank you so much for being here today.
Thanks for having us, Ben. Thank you.
That's been excellent.
It's powerful. It's a noble pursuit, right? Because in our lives these days, there's a lot of noise. I get the monkey mind all the time. There's so many thoughts running around in my thinking mind, and it's hard to tune in to that part inside that's quiet and hopefully wise. And I find that on a bicycle more than I find it anywhere else. And so I personally appreciate it, and it inspires me that the work that you're doing helps other people have that kind of clarity, that kind of peace, those kind of moments that really last a lifetime, and it's not a small thing. And the people tuning in today, we know that you know that, and we're thinking about you when we're creating these products. So thanks to these two, you represent a massive team that realized this product, and it's all in pursuit of a better ride for you. So to you, thanks for tuning in to the Specialized podcast. I'm Ben Capron. Be sure to tune in the future where we talk to the riders and the creators who are helping to shape the future of cycling so that your ride can be a little bit better. And until next episode, be safe out there, have fun riding your bike, and may you find that purity of riding experience that we all relate to so much. Take care.